Welcome to LNP Renewable System Data. Today we are going to discuss some of the basics about solar off-grid system. Okay, and we had classified the session in two parts. In the part 1 we will discuss some of the things. Okay, and rest of the things we will discuss in the part 2. Okay, come, let's get into the topic. So we just want you to visually think about the things when you are planning for an off-grid system. Mostly we will prefer this off-grid system for homes where they need the backup power also during the power cuts, and also they want to get charge the entire system with the help of the solar. Because when you go for an on-grid system, if you are using your power sources during the daytime, mostly in the normal sunshine days, then it is better to go for on-grid system. Okay, but no, you are using only in the evening time or in the sleeping hours, okay, night time, then in such cases it is better to go with the off-grid system. Because even though when you compare the cost wise, for the investment wise little costly, but when you compare with the on-grid system, it has much advantages. Because you can charge the system with the solar, and also you can utilize the charged system during the power cut times. Okay, so when you plan for a off-grid system, make these things should be in your mind. First thing is that how much load that you want to control using this off-grid system. Okay, so based on that, there are so many design steps, procedures that you need to follow. It will be pretty easy for you, but most importantly, whenever you go for a system, these things are very much important. If you're planning for an off-grid system, in the two different ways we can plan this off-grid system. One is with solar panel, MBBT, normal inverter, and solar battery. Okay, with the help of these things, and also the required connecting DC wires, you can plan an off-grid system. In the other way is that instead of going for a separate MBBT and a separate normal inverter, you can use an inverter with the inbuilt MBBTs also. In such cases, you can directly connect your solar panels with your inverters and your off-grid batteries with your solar panels. Okay, like this also you can plan your system. So we can show you pretty much clear details about how you can design your system. This is some of the typical wiring diagrams, how solar panel is getting connected with the MBBT, and how we are connecting our MBBT with the normal solar batteries and our inverters. So whenever you design your system, okay, it is better to provide the proper DC MCBs in the DC side, and also AC MCBs on the AC side for the isolation purpose and also for the protection purpose. So the main usage of using these normal MCBs is that it will protect us from open circuit and the short circuit issues. Even though if there is any ground fault issues also, it will protect. So always try to design your system, okay, before pulling the cable. Always plan properly how much DC rated MCB is required, plan accordingly. Okay, and this is one of the other system where we have a solar charge controller separately. We have a normal inverter in the battery, and using the solar panel we are charging our normal MBBTs. So this is one of the off-grid system. As I told earlier, either separately you can have a MBBT controller. Okay, you can charge your battery by connecting it with the battery terminals in the MBBT, and also you connect your solar PV module in the PVs as shown in the wiring diagram, and you can connect the output of this MBBT, that is line neutral output, to your normal inverter, so that you're charging your batteries with the help of this MBBTs. Okay, and you're running the entire backup system with the help of the solar power only. You're not at all using any EB supplies. Okay, and most importantly, for the MBBT to work properly, it needs some main power supply. Okay, and so let's get into the topic. Today we are going to discuss what are the steps which are involved in designing the solar off-grid power system with an examples also. So see here, this is one of the animated videos for your easy understanding. If you are planning for a solar off-grid systems, okay, for sure sun is going to help you with the help of the solar panels. You are going to charge your batteries with the help of the solar inverters. Okay, and you can connect your AC loads along with it. Okay, so there are 9 steps in designing the solar PV model. First thing is the planning. Okay, and the second one is the collection of informations, and the third one is the load calculation, and the fourth one is sizing of solar arrays, and the fifth one is deciding battery capacity, and the sixth one is selection of charge controllers, and the seventh one is deciding the inverter capacity, and eighth one is structure, and the ninth one is wiring. Okay, so among these 9 steps, in the first part we will discuss around first 6 steps, and the rest of the other 3 steps we will discuss in the part 2. So as we told earlier at the starting of the session, I wish to tell you that there are 5 P's which is very much important for any sort of project. That is, proper planning prevents poor performance. Okay, so planning is very much important when you are planning for a solar off-grid system. So first thing is that collection of information. That one, you need to know what is your load, what is your application, okay, what is your voltage system, whether you have a AC system or a DC system. Most probably in our homes we are having a AC system. What is your daily consumption, okay, and what are the critical loads, okay, and what is your monthly or weekly load profile. So those things are very much important in calculating the load. And next things, the climatic conditions, okay, whether most people will think that climatic conditions plays important role, because for the hill stations, in the hill stations, when you compare the temperature from the normal plains and the hill station, in the hill stations the temperature is pretty cool. So in such places we might thought sunlight won't be much better, so the production won't be less. But for your information, in the normal plain areas, okay, because of the highest peak hours, highest temperature created by the sun, there is a possibility for the energy losses. Okay, but in case of hill stations, the power generation is better, and the temperature losses are very less during the cold seasons. So make sure that even though it is a cold climate or hot climate, how much UV radiation you are getting is very much important. And also there should not be any sort of losses which should happen owing to the temperature, because temperature create energy losses. So make sure, keep this in mind. In the cold areas the protection will be good because the temperature loss is very less. Whereas in case of the normal plain areas where the hot climates, you might think that the temperature might be is high, so that the production will also be if the temperature increases, there is a possibility for energy losses. So always keep this in mind and design your system. So consider the climatic conditions, very much important. Okay. Next, user compatibility. So you need to understand the technical issues, okay, and also budget constraints are very much important. How much budget the customer is asking, those everything you need to collect the information and keep them in the mind. Okay, what is the purpose that we are going to serve, whether we want to provide them the on-grid system or off-grid system or hybrid system. Because when you plan for an on-grid system, if they are utilizing the entire solar energy in the morning hours, if they are doing any sort of works continuously in the morning hours, then for them it is better to suggest the on-grid system. But no, they are utilizing, they need only the power during the sleeping hours and in the morning few hours, means then for them it is better to suggest the off-grid system along with the solar. Okay. No, in certain places some people may say, I need the energy storage also, I am ready to invest in the hybrid. Then for such people you can provide these details. Okay. First thing is that we need to do the load calculation. So for the load calculation, so we can classify them into 2. One is for the DC loads and for the AC loads. So here DC loads means most probably your batteries are going to be the DC loads in most of the houses. There are certain people who try to use the DC power directly for the lighting purposes. Okay, so you need to know the how much load amps and how much operating hours per day you're going to plan, so that you can finally sort it out. Amp hour per day for a DC load you can calculate. Okay, and the next thing is that for if you're planning for an AC load, then you need to know what is the wattage of that AC load and how much hours you're going to operate it in a day, so that you can able to sort it out the watt hour per day. And also after calculating the watt hour per day, if you want to calculate the ampere hours per day, then you need to divide the watt hour per day divided by the inverter efficiency and the nominal system voltage, because nominal system voltage is very much important. Because for a system, okay, you can provide a backup with the help of a 12 volt system, 24 volt system, and even with the 48 volt systems also you can provide the backup support. So in such cases you need to keep the nominal system voltage that you are going to plan, because based on the nominal system voltage your load value will also differ. So always in order to know the inverter efficiency, you need to know you need to study the inverter data sheet. how much its inverter efficiency, and also what is the nominal system voltage that you are going to plan. You can plan 12 volt, you can plan 24 volt, or you can plan 48 volt. Those things are very much important in to calculate the ampere per day. Okay, and this is simple load calculation. We have given you crystal clearly. Okay, you can segregate room wise. Okay, you have a kitchen, you might have a bedrooms, you might have a laundry or bathrooms, you might have a lounge or entertainment areas. So you can classify your load and appliances like this, and you need to know the power of individual equipments, which is appliances which are available in your home, and you need to know average time period. Okay, how much quantity it is available, and you need to know how much average hours you are going to run the entire system, so that as we told in the previous steps, you can able to sort it out the amperes per day, watt hours per day using these values. Okay, so first thing is that sizing the solar array. So you need to plan how many panels that you're going to connect in series and how many panels you're going to connect in parallel, because as I told earlier, based on your nominal voltage, say for example, when you connect your solar panels in series, the voltage will increase. Say for example, if you're connecting a 12 volt system in series, so what will be the output? It will be a 24 volt system. Then means if you're planning for a 24 volt system, then what you need to do, you need to have a, if you're planning for a backup, then you need to have a 2 batteries. Okay, you need to have 2 battery systems which will operate in a 24 volt, so that you need to plan accordingly. Or you are planning only in a 12 volt system, then what is the most important thing that you consider is that you need to connect your system in the parallel, and on also you, when you connect your solar panels in parallel, what will happen? The current will increase. So both the things you need to keep in your mind. So there is a formula for calculating everything. So you need to know when you're planning for a number of series modules, then divide your nominal DC system voltage divided by the nominal voltage of the solar modules. If you're planning for a number of parallel modules, this amperes per day is very much important, and the module derating factor is very much important. What is the panel that you're going to plan is very much important. This data will be available in the data sheet of the solar panel. And also battery AH efficiency is very much important. Say for example, you're planning for a 100 AH solar battery or 150 AH solar battery. When you study the data sheet, you will be able to sort it out what is the efficiency of that concerned AH. Okay, and also you know maximum current of the module, you can sort it out with the help of the data sheet of the solar panel. Okay, and this solar insolation of the first month, that you can keep based on your requirement, or you know we can't assure that for all the 12 months there will be a good protection. There are certain months which might be a worse months, so consider them in your calculation as well. Okay. And as we told earlier, in the final, you need to sort it out with by sorting them, how many panels you're going to connect in series and how many panels you're going to connect in parallel. Finally, you need to add both of them, and you need to sort it out how many number of modules that you're going to for a solar array, so that you will finally able to sort it out what is the capacity of the solar array that you're going to plan. Okay, and most importantly, keep this in mind. Okay, always make design that normally you know the minimum efficiency of your panels might be around 19% or 20% or 21.4% efficiency. So in such cases, please make conscious decisions in your planning. Say for example, you know when you're planning for a 1 kVA system, then your solar panel, at least you need to plan minimum 1.2 or 1.4 or 1.5. If it is more than that, then it is good, because if you want an efficient output of 100% output you can't expect in the solar. Okay, so because there are certain days the production might be good, there are certain days the production might be very less. So always you know design with the higher solar arrays, so that you know inverters you can plan for 1 kVA. Okay, inverter you can plan for 1 kVA, but you know the solar panels you need to give a higher one, 1.5. Then the inverter, then you can go for a 2 kVA. If you want an exact 1 kVA output or a 1.5 kVA output, exact efficient output, then you need to go for a 2 kVA solar panel, and you need to have a solar array of around 1.5 kVA. Always you know like this you need to design from the starting. Okay. And next thing is that deciding the battery capacity. So battery capacity is very much important, because for the residential load you might have a battery backup for 3 to 5 days. For the industrial loads, you need to for 7 to 14 days. Okay, and most importantly, during the poor weather conditions in certain places, you need for 7 to 14 days also. Okay, so always keep this in mind for where you are going to design, whether you are going to for a normal residential or you are going for industry. So when you are planning in such ways, keep these things in your mind. Minimum this much backup our system should provide. Okay, and most importantly, when you're deciding the battery capacity, check the manufacturer recommended maximum depth of discharge. It can be an 80% deep cycle or 15% shallow cycling, and also if there is any temperature variations, okay, what will be the recommended design which is given by the battery manufacturer. Keep that also in your mind when you're planning for a battery capacity in AH. Already we had calculated the amperes per day. Into you need to calculate the number of backup days divided by the maximum depth of discharge. These details you can find it in the battery data sheet. Okay, as we told earlier, how much batteries you're going to connect in series, how many batteries you connect in parallel, that also very much important, because if you want to calculate them in precise, first you need to know for a DC system, in order to connect the batteries in series, you need to know what is the system DC voltage and what is the battery voltage. And if you're going for a parallel system, you need to know the total AH required and the AH of the individual batteries that you're going to connect. And as I told earlier, you can design your system directly, you're connecting your solar panel with the inverters, and you can connect your battery backup with the inbuilt inverters which has a MPPT feature. Okay. Or you can connect it with the charge controller. What is the purpose of connecting with the charge controller? Very simple. In charge controller also there are two varieties, PWM type and MPPT type, but it has it will protect you against the surge. Okay. And also prevent the discharge of the batteries to the solar panel during the night, and it also provide overcurrent protection, overcharge protection, reverse connection protection, and it also controls the temperature set points. And most importantly, if you want to improve the voltage, you can go for the PWM. Okay, it is normally what is available, the same thing it will boost up and give. And if you plan to improve the current, then you can go for a MPPT charge controllers. Okay. And if you want to calculate the charge control, then you can use number of panels into the short circuit current of that concerned panel. You can see it in the data sheet into 1.2 times, so that you will try to get a value in amps. So it is the capacity of the total charge controller. It might be in the amps. So what you can do, which is closer to it or which is higher than it, you can go for. Say for example, if you are getting a value of around 35 amps, then you can go for a 40 amps charge controller. Or if you are getting around a value of 15 amps or 16 amps, then you can go for a charge controller of 20 amps value. Okay. And structure is very much important. So if you want to calculate the number of structures, first you need to know the total number of modules. This one already we had calculated when we are calculating the modules that we are planning to connect in series and the parallel connection. So now we will know the total number of modules. Divide the total number of modules by the number of modules of single inverter. Say for example, you can connect two modules. Okay, you can connect how many? You can connect two modules in a single structure. Then say for example, you are going to connect around 20 number of modules. Okay. Then 20 divided by 2, so what will be the answer? 10. So it means the number of structures is going to be the 10. Okay. So as we told earlier, in the step 1 we had discussed how to determine the DC load, and in the step 2 we had able to calculate the AC load and how to convert it. Those things we sorted out. And third important thing is that we had determined the total system load. Okay, and in the fourth step, so we had determined the total DC ampere per day. Okay, so if you want to calculate convert the watt hour per day into ampere per day, what you need to do, divide the watt hour per day divided by the nominal voltage. Here we get given an example. Here the nominal voltage of the system is going to be 48 volt. That's why we are dividing the 3100 watts per day divided by 48, so that we will try to sort it out to the 73 ampere per day. And in the step 6, we are going to determine the total ampere per day along with the batteries. means already in the last step we had sorted out the total ampere per day, that is 73. So we are dividing that with the battery efficiency and the model derating factor. So these two details you can get it from the battery data sheet and the module data sheet. Okay, so we will try to get the 100 ampere per day, means then we can determine the total PV array current, that is total daily ampere requirement divided by the design isolation. It can be a 5 hours, so it means 20 amps. Thank you so much. Please subscribe and press the bell icon. Okay, and this is the part 1 video. In the part 2 also the continuation of this is going to be there. So we are providing the link in the below section itself. So once you listen to this part 1, you, by referring the other link, you can refer the part 2 as well. Thank you so much. Please subscribe, and if you want to know more and learn more, you can contact us. If you want to do project business, you can contact us. We have provided the contact details here. And also, you know, if you're really interested in home automation, the building automation industry, and if you are a student or diploma or electrical and electronic BE engineering student, electronic and instrumentation engineering student, if you want to work in a GCC like countries in the building management system or building automation system, or if you want to know the PLC basics, okay, if you want to know the solar DC lighting systems, and if you are really interested to do projects with us, you want solar fencing kits, we are also providing it. And if you want a design, installation, testing, commissioning support for solar on-grid and off-grid, hybrid, and even solar pump services also we are providing, you can contact us. And if you are planning for any access control system in your home, okay, we are providing design, installation, testing, commissioning support. And for the PLC training, we are providing Siemens, Amtrol and Delta. Along with the certifications, it will be a value-added certification, so that you will get a wonderful job opportunities in Gulf countries as well as in India as well. So we have provided the contact details here. You can contact us. Thank you so much. See you in the next video.